So in this video, we're looking at three-phase transformer calculations. So the formulas that you would mostly use are these on the screen. Don't forget that P is the true power, S is the apparent power. And so most cases, these are the two formulas that will be used the most. Okay, then we also get S is equal to root 3 VL IL. Okay, and so either you're going to use only the ones or you're going to use the twos. So remember, when the transformer has no losses, the input is equal to the output. And so there's always a transformation ratio, which is N1 is to N2. Okay, and these are the formulas that you would use. Remember, when using the N1 versus N2, you're going to use the phase values, okay, when using that formula. And when using the formula right at the bottom, this one is only phase values. And when using the true power formula, P is equal to root 3 VL IL cos theta, do remember that those are the line voltages. So with delta, the voltages are the same. With star, the currents are the same. And that's how you need to remember this. Remember that the primary is on the left hand side, which is N1, and the secondary on the right hand side, which is N2. So in this question, what's nice about it is that it's given us the drawing, so you don't have to draw it. If it's only words and no drawing, you must draw your drawing so that you can understand the question and you will then know how to answer it. So don't forget that we only use volts in the substitution and not kilovolts. Right, so looking at the question at hand. So the question says the secondary line currents. So definitely what was given was power in, right? Power in is 200 kilowatts. We will not use kilowatts, but rather use watts. Remember, if there's no losses, power in is equal to power out. We also have the secondary line voltage, which is 400, and the question is asking us for the secondary line currents. So obviously you have to use two secondaries. You can't use one secondary and one primary. And we also have something called PF, which means power factor, and power factor is cos theta. Do note that PF is equal to 0,8. That is not the angle, that is cos theta. So this is the formula that is used most of the time. So what you're going to do, you're going to substitute the values. Pause the video and see if you can do it. Notice we're going to use all the secondaries. Why? Because we are looking for IL2. You will then need to make IL2 subjects of the formula. In other words, divide everything on the right hand side by root 3 VL cos theta. Right, and then divide the left hand side by the same, and this is how you'll have only IL2 left on the left hand side. Hope that makes sense. Right, substituting the values, we say the power is 200,000. VL2, which is the secondary line voltage, is 400. Cos theta is 0,8. And that gives you 360,84 amps. Remember to punch this in as 200,000 divided by open brackets, plug all that in, close brackets to get the answer, or you can use the fraction mode. Right, and that's 541. 542, the question says apparent power. Don't forget that apparent power is S. Right, these are formulas for calculating apparent power. Do note in this question that you do have the true power already. True power is P, so you're going to calculate S. Do you have power factor, which is cos theta? Yes. Making S subject to the formula, divide both sides by cos theta. Then substitute your true power and your power factor. Plugging that into the calculator, we should get 250,000 amps. And don't forget to write that also in kilovolts amps. And so apparent power is volt amps or kilovolt amps. The next question, 543, says the primary line currents. This means we are dealing with the left hand side. So we could use the apparent power to work this out, or we could use the true power, it will still work. So remember that apparent power, we leave out cos theta. If we're using true power, then we add the cos theta into the formula. Right, don't forget that this is the primary side, so those will be 1s. So dividing both sides by root 3 VL1 on both sides, this would become IL1 on the left hand side. Substituting into the formula, don't forget that the parent power is now 250,000. Don't forget that VL1, according to the diagram on the left hand side, VL1 is 6,000. So substituting that and working it on our calculator, 24,06 amps. The next question, 544, primary phase current. So remember, we got the formula I phase is equal to IL over root 3. So that's the formula we can use. Remember that this formula only works with the I's, okay? So I phase, IL. Don't go and use voltage and current, okay? So if you're finding the voltages, it will be V phase is equal to VL over root 3. So now we're going to substitute our line current of the primary, which we just worked out. Substituting that in, punching it into our calculator, we get 13,89 amps. You must put the units when working these questions for the whole of electrical. So the next one says to calculate the turns ratio, in other words the transformation ratio, and we can do that very simply by using N1 over N2. But do note that N1 over N2 is not given, and don't forget N1 over N2 is equal to V1 over V2, which is equal to I2 over I1. So do note that the windings, which are the N's, and the voltage, which are the V's, they are directly proportional to each other. Do note that the currents are inversely proportional. So you can either use any one of those three, depending on what numbers you have. We do note that you don't have the windings, we don't have the number of turns, so we'll have to use either the voltages or the currents. We do have both currents, so you can use the currents, and we do have both voltages, so you can use the voltages. Do note that we only use phase values in these questions, okay? So with this question, we can only use, in this formula, we can only use phase values. Do note that. So noticing on the diagram, we do not have the secondary phase voltage. This means you're going to have to calculate it. So the phase voltage is not given on the secondary side. Do notice that on the secondary side we have what we see as a star. So just after the 3 lines of the transformer we have a star on the secondary side, okay? This means we have 2 different voltages, and there was given was VL2 in the diagram, which is 400. So 400 divided by root 3 will give you that phase value. So 400 divided by root 3 on my calculator, that will give me, we can't really see that in the screen, but anyway, it'll give us 230,94. Right, and that's as volts. So both those values are volts, but do note that there's no unit on the transformation ratio. It's practically just a ratio. So the ratio there is 25,98 is to 1. And we can round it off and make it 26 is to 1. Okay, and that is the first question that we did. Right, we're going to look at a second question. Pause the video, make sure you have all the correct answers. Okay, with the next question, we can see clearly there's a diagram and all the values are on the diagram. There's nothing missing, so they do list it for us, so it makes it kind of easy. Okay, so remember the left hand side is the primary, right hand side is the secondary, and PF is cos theta. Right, the first question says 531 line current of the load. Okay, so it uses the word load. So when you see the word load, you must know it's secondary side. Right, in this question, they gave us the power. Do note that the power is given, power factor is given, the secondary line voltage is given. The only one that's not given is the secondary line current. And the first question says the secondary line current, which means the load. Making P subject to the formula, divide both sides by root 3 VL cos theta, only leaving IL2 remaining. And now we can substitute all the values. Do notice that the power given was 300,000 watts. Now, how do we know that that is true power? Because the unit is kilowatts. So substituting that into the formula, don't forget our VL2 was 600. The VL2 is 600. And the power factor is 0.87. Plugging all that into our calculator, I get an answer of 331.81 amps. The second question says the phase current of the load. So we're still dealing on the secondary side, okay, the right hand side. So phase current is I phase 2 is equal to IL2 over root 3. On the left hand side, okay. So the first two questions was right hand side, and the third question here is left hand side. Primary means it got to do with all the ones in the diagram. So looking at the question, looking at the diagram very nicely, you will notice that on the secondary side there's a star system. Now star system has the same currents but different voltages. So this here, the question says it's a delta star transformer. So it's a star on the secondary side. And with star, we know that the currents are the same. Voltages are different. So I phase 2 is equal to IL2. In the next question, they're asking for the primary current. So we're going to use the formula that's very similar to 531. So our true power, we can substitute it. It's going to be very similar to 531. Substituting 300,000. Now VL was 6,000. Am I right? 6,000. No, 8,000. 8,000 volts. And the power factor 0.87. It is a good thing to put multiplication signs in between there, so it's easy for you to understand. I just put a dot because of my board space. So do put a times in between, okay? And then we'll get the final answer, plugging it in. And we get an answer of 24.89 amps. We're going to go on to the next question. Okay, so in the next question, we can see the diagram. On the left hand side, we have VL1 is equal to 22,000 volts on the primary side. And on the right hand side, we can see VL2 there is given. So this is 7.7 kilovolts. So do note that this is a delta star configuration, and it's a step down transformer because the voltages are becoming smaller on the right hand side. So if your voltage on the left is greater than the right, it will be a step down transformer. If the voltage on the left is smaller than the right, it will be a step up transformer. Do note that transformers step up or step down voltages, not currents. Do note that. So this is how we determine whether it's a step up or step down, by looking at either the N's or the V's. Remember that N and V are proportional to each other. So this is a delta star transformer, and it is also a step down transformer. Do write both answers just to play it safe. The question says calculate the secondary phase voltage. Do note that it is a star on the right hand side. Star has two voltages, a phase and a line voltage. So we're going to calculate the secondary phase voltage. So we are looking at the right hand side. So in the diagram, the voltage is given on the right hand side. It is 7,700 volts. Plugging that into our calculator, we get 4445.60 volts. Just a reminder, you must use a formula, a substitution, and a correct unit for every question. Just reminding you. Right, the next question says, calculate the transformation ratio. So the transformation ratio is noted as N1 is to N2, always. Right, so we can either use the windings, N1 versus N2, or the voltages. In the question, there's no N's given, so obviously we're going to have to use the voltages, and it will always be the phase voltages when using the fraction formula. So when I say the fraction formula, that is N1 over N2 equals V1 over V2. So V1 is 22,000 volts. Why? Because delta V phase is equal to VL. So the line voltage and the phase voltage are exactly the same. with delta configurations. Okay, so the primary side is 22,000 volts. Let's look at what the secondary side will be. So will it be 7,700 volts or 4445,60 volts? Which one will it be? Remember that the formula, you have to use phase values. So the phase value we just calculated in the previous question, in 532, we calculated the phase value. And that's the phase value substituted. Do punch in your calculator, you'll get a transformation ratio of something is to 1. So it'll always be something is to 1, then rounded off if it's a decimal. So we'll get 495 is to 1. Okay, and so you could round it off to 5 is to 1. So I would say write both answers. And that is estimated at 5 is to 1 or rounding off. Right, 534 says calculate the apparent power. So remember that the formula for apparent power will be S is equal to root 3 VL/IL. Right, so notice on the right hand side we do have the line voltages. Right, so with this formula we have to use line values. So we can use the line voltage on the right, and we can also use the line current on the right. And we can see our line voltage there is 7,700. And if you look at the diagram right on top on the right hand side, it does say 40 amps. Do remember with star, the currents are the same, the voltages are different. Plugging all that into your calculator. Don't forget that our unit is volts amps, so we get 533,471,65 volts amps, multiplied it with 1,000 to write it in kilovolt amps. And that's in kilovolt amps. There's also efficiency that we normally calculate with these questions, but I'm just doing all the left hand side, right hand side transformation ratio type questions. Okay, where we're doing between left and right. In another video, I'm going to cover all the efficiencies. Now in the next question, there's no diagram. It's all in words. And so now it becomes a little bit of a mission. So this means you're going to have to draw a diagram. So first it says a delta star transformer supplies a mole with power 50,000 watts. Then it says the primary line voltage is 11,000 volts. And the secondary line voltage is 380 volts. Now this question doesn't say the power factor is, it says the phase angle is 24,56 degrees, that is theta. Now the first question says the secondary line current, this will be 571, the secondary line current. So this means we're using all the 2's. So IL2 is equal to, and that's how we make IL2 subject to the formula as done before. Right, now we're going to substitute our voltage, but do note we don't have cos theta given as a value. Instead, they gave us the angle. So you will need to write the word cos there. Our power is 50,000 watts, and we know that VL2 on the right hand side is 380 volts. So 380 volts. And then cos 24,56. This will give us 83,52 amps. 572 says the transformer ratio. So the formula is N1 over N2 is equal to V1 over V2. And we know on the left hand side, we got 11,000 volts, which is a phase value. So do notice with delta, the voltages are the same, but with star, the voltages are different. Notice the question said the secondary line voltage is 380 volts. So that means we're going to have to find the phase voltage. V phase is equal to VL over root 3. And that's going to give us 380 divided by root 3, and we'll get a final answer of 219,39 volts. Plugging our ratio into our calculator, it will always be something is to 1. We'll get 50,14 is to 1, and then round it off as 50 is to 1. The next question says the primary current, so we go into the left hand side. So 5 373, calculate the primary current. Right, so to find the primary current, we can use the fraction equation where the currents and the voltages are inversely proportional. Don't forget V1 is to V2 will be from the transformation ratio, which is V1 is to V2. So because you're finding the primary currents, you can swap the formula over, put the numerators in the denominator, denominators in the numerator, make I1 subject to the formula. In other words, multiply both sides by I2 to get rid of I2 in the denominator, which is here on the left hand side. Okay, so get rid of I2 by multiplying by I2 on both sides and then substituting. Do note that now we have V2 over V1. So let's go back to the first question to get our I2. So notice here, our I2 was here, right? I line 2 was 83,52. So do notice we have star on the right hand side, meaning that the currents are the same. So with star on the secondary side, our currents are the same. So this means we can take that line current. So I line is equal to I phase for star systems. So I line is equal to I phase for star systems, and the value is 83,52 amps. So 83,52 times 1 is 83,52 divided by 50. And so our primary current is 1,67 amps. Do note what happened in this question. So when you're getting such a low value, you would consider that there's something wrong with the question. But let's look at it. Do notice I1. I1, we calculated it to be 1,67 amps, right? Notice I2. I2 is 83,52 amps. So notice that the voltage was being stepped down. In this question, this is a step down transformer from 11,000 volts to, what is our voltage that we came down to? 380 volts. So notice the voltage went down, but what must happen to the current? The current must go up. So if I started on the primary side with 1,67 amps, this means the voltage must, the current, must increase to a bigger value. So if the voltage goes down from 11,000 volts to 380 volts, this means the current's going to do the opposite. It'll start off low and end off high. And notice in this question, that's what happened. So the current became larger. Why? Because the voltage became smaller, and we base whether it's a step up or step down based on voltages. So notice that the voltage did go down from 11,000 to 380 volts. That was the given information. So this is a step down transformer, not a step up. So a question they could ask you next, is this a step up or step down? And most children will look at the current and say it's a step up. Don't get caught. I'm going to have to wipe the board, so make sure you have this information. So 534 says calculate the apparent power. So the formula for apparent power is √3 VLIL. With the apparent power, there is no cos theta. And do notice that that is not P is equal to, but rather S is equal to. So VL2, we notice we have 380 given here. VL2 is 380 and I2 is 83,52 written on the right hand side of the board. So plug that into the calculator. That'll give us a unit of volt amps because it's apparent power. Divide that by 1000 and you'll get kilovolt amps. Okay, and that is the apparent power. In the next question, it says a star delta connected transformer has 100 turns per phase. So 1000 turns per phase on its primary and 100 turns per phase on its secondary. But confusing. Right, so 1000 on the left, 100 on the right. My eyesight's not so good. If the transformer is supplied by 1000 volts, so notice it says supply. So this would mean the primary side, supply side. So question 1 says the primary phase voltage. So you know that V phase is equal to VL over root 3. Remember, on the left hand side we have a star system. This means there's two voltages. What was given was the line voltage, so 1000. So now we're going to substitute 1000 divided by root 3 and we'll get an answer of 577,35. Now the second question says the secondary phase voltage. So this means V2 will be on top, and you can only use phases in this formula. So in this formula, notice that V2 will be on top because that's what you are trying to calculate. Multiplying both sides by V1 to make V2 subject to the formula. Notice that N2 is 100 and N1 is 1000. And now we have 0,1 times 577,35, and our final answer there will give us 57,74. And that's the secondary phase voltage. Now 583 wants the turns ratio, which is already on the screen, but do note it's kind of tricky because it must be N1 versus N2, not N2 versus N1. So it's going to be 1000 divided by 100, and that will give me an answer of 10:1. In your time, you can experiment by using the phase voltages of V1 and V2 and see if you can still get the answer of 10:1. If you try this out, you'll have full understanding. So notice on the left hand side we have 1000 volts, and that was made into a primary voltage. So if you can calculate the V's, it can work out. Okay, so let's just do it quickly. So now we calculated using the voltages V1 over V2. It's a good idea, but notice it doesn't come out perfectly accurate because of the rounding off in the previous questions. Do you see it? But do note, once you round off the final answer, you will still get 10:1. So you could use the voltages, but for a more accurate answer, it would be best to use the N's because it's given N1 versus N2. So remember, with all calculations, try and use the givens if you can. Try not to use your calculated answers unless you have to use your calculated answers for the next question type of a thing, but always work with the givens where possible.